So at the moment I'm looking at the low power modes of the Epaper and the STM32. So at the moment this is running in a loop with the low power STM32 library, and I'm putting it into, what is it, deep sleep mode, and then waiting for about a minute, and then it'll wake up and update the display and then go back to sleep again, which is fairly basic function. I mean, it's got the real-time clock that runs all the time off the battery supply, and that's what the time is that's displayed here. I've got some leftovers from the test pattern. I'm not really too bothered about that at the moment. And it looks like when the display and processor are in deep sleep mode, it's taking 3.2 milliamps, and that's nowhere near good enough for running for any sort of period of time on a 2032 cell. So I tried low power shutdown mode, and that does seem to shut the STM32 down, but the display itself seems to still be taking a milliamp. So that's even when I put the Epaper display into sleep mode. So even a milliamp, that's no good. That's just going to be 90 hours. So what I was hoping to do was shut everything down and then just wake up. Maybe only when I press the button, or maybe once every 10 minutes or something, so that the Epaper display's off and the STM32 is in its lowest power mode. And that should give me a lot less than a milliamp. So I've tried removing the display while it's in this mode, and it does seem to be the display. The STM32 in shutdown mode seems to be taking hardly anything at all. So it's like 1, maybe 2 milliamps for the Epaper display, depending on whether it's in deep sleep mode, or, well, sleep mode or not. I think it does call it deep sleep mode actually for the Epaper display, in the data sheet, not in the code. It's all a bit confusing with all the different sleep modes and so on. So I'm not sure why that is. I'm not sure why I can't shut the Epaper display down. I'm hoping I don't have to put any transistors on there to actually turn the supplies off, because that's going to get a bit, well, a bit large in terms of component count. I have had it running off the 2032 now that I've reduced the clock rate on the STM32. If you run it at 48 megahertz, I think it's running at, you end up with a current consumption of about 30 milliamps, which just flattens the battery. It pulls the voltage down to a level at which the processor won't run anymore. So I'm now running directly off the crystal, so that's an 8 meg clock rather than a 48 meg PLL output, and that's sort of a few milliamps, 10-12 milliamps, which is still too much. I may have a go at reducing that even more, but at the moment the big problem I've got is not being able to get into a low power mode, or low enough power. I mean, a milliamp's not a lot, but it's way too much to run off one of these cells here. So the code is really simple. I've got buttons and so on. I have found that if you're in the sleep mode, any sleep mode on the STM32, then you can't use the ST-Link to program it again. You actually have to have it running. So the way I've done that is if I hold a button down at power on, it jumps into a recovery mode, which is just sitting in a while loop waiting to be programmed. That works quite well. The only way I managed to recover this PCB the first time I put it in a sleep mode was to use the STM32 Cube programmer software, which is designed to talk to the ST-Link V2. It took a little bit of effort to get that installed on my machine, but once I did, I managed to hold the processor in reset with a wire link and then connect using the ST-Link V2 in its reset mode. And then once you're connected that way and the processor's held in reset, you can then erase all the flash, which is what I did. I just erased the entire chip, and then I was able to program it with the ST-Link V2. So that was a bit of a moment when I thought I may have bricked my PCB, but it looks like it's almost impossible to brick these things. There is a way out if you can get all the utilities loaded on your computer. So anyway, at the moment I'm still fighting to get this thing low enough power for it to run more than 7.5 days. I calculated was my lowest power mode so far on a 90 milliamp 2032. So, or sorry, 90 milliampere hour. I'm not sure entirely really what the capacity of a 2032 is. It does depend on whether it's rechargeable or not rechargeable, and probably where you buy it from and how much you paid for it. I've seen figures as high as 200 milliampere hours and as low as 90, so I'm working with 90. So if I put a nice 200 milliampere hour one in there, that'll be quite nice because it will double whatever figures I've managed from my 90 milliamps, 90 milliampere hours. So yeah, still fiddling with the low power modes at the moment. I'm not sure really whether this Epaper display, I don't know what's up with it. I've got a different display. This is the 3-colour one. That was from Buy Display, and they had a black and white one, but it didn't do partial updates, or it sort of did. It just looked a little bit scrappy on the display. So this one is from a company called Good Display, and that one does support partial updates, which I'm not using at the moment. It does support them better than the Buy Display, but I still wouldn't say it was amazing. But it may be the way I'm driving them. So this is actually a different display. Nice little touch. The connector, the pinout, is identical between the two, so I think that must be some sort of standard for maybe price tags or something. So I managed to buy a display from a different manufacturer or a different supplier, and it's a different model. Used the same controller chip, which was nice, and just plugged it in and it worked. So I was quite happy with that. So that's what this display is. It's a different display to the original that I had. I might swap back and see if the low power mode's better on that. Deep Sleep Mode 2 I think it is. But at the moment I need to check the data sheet for the Good Display actually. That may be a different value for the Deep Sleep Mode, but I can't believe it's 1 milliamp. That's just ridiculous. So that's what I need to look at next.